Thomas Kokin, former NASA science director, shared thoughts on the launch of the James Webb Space Telescope, marking the beginning of a new era in astronomy. Webb is poised to expand and test our cosmology and our understanding of planets and the origin of life. What began hopefully turned into a debacle. James Webb shocked scientists with a crisis. Will the crisis now get worse? Or will a new discovery of the James Webb Telescope end the debate in physics? The discussions about old theories and who is right or wrong come to a temporary end. But what exactly does this mean? Have scientists really unraveled the mystery surrounding James Webb's impossible discoveries, or are we just being stalled with flimsy explanations? James Webb was supposed to bring solutions, but instead, the $11 billion project plunged cosmology into a major crisis. All parts of natural science associated with space are currently experiencing a shakeup of the kind we last saw in the Middle Ages, with a shift to the heliocentric view of the world. Now, we may have to recognize that the foundations of our modern physics are also flawed, and that we have not come close to understanding what our cosmos really is. But how is this possible? Today's astrophysics, or in other words, the science of the physical quantities and relationships in the cosmos, is based on the basic rules of physics, which essentially go back to researchers of antiquity, the Middle Ages, and in particular to Sir Isaac Newton. The first observations of mechanics and dynamics were made in antiquity. Quantities and forces were described for the first time, and later Newton discovered gravity, which is so important for astrophysics. We built our scientific observation of the universe on these foundations. We transferred the quantities and forces that were valid and observable on Earth to the universe, and this produced some consistent results. But then the space we can see got bigger and bigger, and at a certain point, our known quantities did no longer fit to describe what we see. This crisis began with the problem that different methods of measuring the age and expansion rate of the universe led to contradictory results. Local measurements based on astronomical objects within the universe gave different values than measurements of the early universe based on the cosmic microwave background radiation. We know this dissonance as the Hubble voltage. While the Hubble constant indicates the expansion rate of the universe, in the summer of 2022, Webb discovered so many old and highly developed galaxies in space that doubts arose as to how the age of the universe was determined. Our cosmos can hardly be 13.8 billion years old if, thanks to Webb, we see galaxies that were already well developed 200 to 300 million years after the Big Bang. According to the calculations of our physics, galaxies need billions of years to grow. In the case of the galaxies discovered by Webb, this would even mean that the time of their formation was before the Big Bang. Our old cosmology, according to which the universe began with a Big Bang 13.8 billion years ago, has been expanding ever since and has undergone a slow process of evolution of matter, cannot be correct. We are at a crossroads. Either we are making a mistake if we think that our earthly physics can be applied to the entire universe, or we have so far only deciphered a small part of the physics that really exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." According to this maxim, all the physics that exists in the cosmos should also be found on Earth, but perhaps we have overlooked forces and dimensions on our planet that we are now noticing in the cosmos. Webb breaks all records. It's fantastic. This telescope can pick up extremely weak light signals. Webb's 18 honeycomb-shaped mirrors effortlessly detect light that has traveled through space and time for more than 13 billion years. A special exposure method makes these faint places of light visible for the first time. Thanks to the new revolutionary technology, we saw the light from the most distant galaxies that formed shortly after the Big Bang for the first time in the summer of 2022. These galaxies were a sensation and, at the same time, a bitter disappointment. Instead of baby galaxies, Webb shows perfectly developed galaxies that appear to be several billion years old, but with an age of 13.5 or 13.6 billion years, this can never be the case. These days, scientists sometimes say that the objects and the images aren't impossible or not real, but Webb can only show us the truth. Science must now admit that it has probably been on the wrong track for more than a century. That's roughly how old our standard cosmological model is. What we see here is real. Webb works perfectly. It's just that large parts of our science are still unable to come to terms with the new truths. Some of the old traditionalists, who don't want to look the new truths in the face, vehemently oppose the end of the Big Bang or the idea of expansion. In the Middle Ages, it also took many years before the Church was finally willing to admit that the Earth was not the center of the universe, even though there were suddenly masses of evidence from astronomers all over Europe. So not much seems to have changed, and although we consider ourselves much more modern today, we have a similar scenario. Researchers who proclaim something new may no longer end up in prison like Galileo, but the quarrels between researchers and the hostility towards new things are still there. Imagine you have spent a lifetime researching and firmly believing in something, and then suddenly you see images or another side of reality that tell a different story. Perhaps your mind would also rebel against this at first, and it would take a while before you could accept the new truth. As everywhere, there are some who are quicker to adapt and others who take longer. Many open-minded and young scientists are enthusiastic about Webb's discovery. Rohan Naidu, the discoverer of the galaxy Z13, and S.F.L. Stein, who discovered Ma's galaxy, belong to this open-minded generation of researchers. They look at Webb's images with an open mind and have been studying them since the first moment of publication. Both astronomers emphasized several times in interviews that we simply cannot know what will happen in astrophysics at this moment. We have to wait for further measurement results, studies, and, of course, Webb's latest images. Was it Hubble's fault? Let's take a look at the dilemma. One of the great debates in modern cosmology concerns the Hubble constant. This is the rate at which the universe is supposedly expanding. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies were moving away from us. From this, he concluded that the universe is expanding. The idea was later expanded upon, and the Belgian astronomer Lemaitre postulated that this expansion originated from a single point, the Big Bang. Today, we already know from alternative methods that the movement of galaxies can also be explained differently, and these approaches also provide a coherent picture in their entirety. However, they were ignored for a long time because the old theories were considered more probable. But the more we see of the universe, the more discrepancies emerge. This didn't just start with Webb. Even 20 years ago, there were regions in space where the expansion was behaving differently. It was as if these regions were sometimes faster and sometimes slower, or perhaps denser or emptier. This led to speculation that there may have been several starting points, or that our universe is even permanently fed by several sources, which do not necessarily all have to have had a beginning at the same time or at all. Alternative ideas about the shape, nature, and age of the universe emerged once again, but researchers continue to cling to the old theories of the Big Bang and expansion. This was possibly a mistake. We have already briefly learned about the Hubble tension. In short, it shows clear differences in distance measurements in the universe, depending on which fixed points we use as measurement constants. Now, scientists hope that the Webb telescope, as its mission progresses, will be able to resolve this tension by making precise measurements of the distances and redshifts of galaxies. The potential correction of errors in previous measurement methods not only represents a crucial turning point, but also holds the promise of ushering in a transformative paradigm shift, propelling us into a new era of advanced physics that penetrates the very fabric of cosmic reality. This monumental achievement stands as a testament to the unwavering dedication and tireless perseverance of generations of researchers who have devoted their lives to unraveling the enigmatic mysteries of the universe, tirelessly pushing the boundaries of human knowledge ever further in their quest for truth and understanding. In their relentless pursuit of knowledge, these intrepid explorers have not only expanded the horizons of our understanding of the cosmos, but have also enriched our collective consciousness, igniting a sense of wonder and awe at the vastness and intricacy of the cosmos that surrounds us. As we stand at the precipice of this new frontier, poised on the threshold of discovery, it is incumbent upon us to approach each new revelation with open minds and open hearts, embracing the potential of even the most unfamiliar or shocking findings to reshape our understanding of the universe in profound and unexpected ways. Indeed, the emergence of new theories and alternative explanations heralds the dawn of a new era in scientific inquiry, where entrenched paradigms are challenged and bold new ideas beckon us forward into uncharted territories of knowledge and exploration. At this pivotal juncture in history, we find ourselves on the cusp of a profound scientific revolution, where the investigation of the oldest points of light in the universe holds the tantalizing promise of unlocking the deepest truths about the nature of existence itself. With the advent of cutting-edge technologies such as the James Webb Space Telescope, we are poised to embark on an unprecedented journey of discovery, delving ever deeper into the cosmic tapestry to unravel the mysteries of accretion disks, probe the enigmatic realms of supermassive black holes, and peel back the layers of cosmic phenomena that shape the very fabric of our universe. Yet as we chart this course into the unknown, it is imperative that we remain ever vigilant against the siren call of complacency, steadfastly resisting the temptation to succumb to the comforting allure of familiar explanations and outdated paradigms. Instead, let us boldly embrace the spirit of scientific inquiry, cultivating a mindset of relentless curiosity and intellectual openness that empowers us to question, to challenge, and to explore with unyielding determination. In doing so, we honor the legacy of those who came before us, building upon their pioneering efforts as we strive to unlock the secrets of the cosmos and illuminate the boundless wonders that await us beyond the horizon of our current understanding. The universe is an intricate symphony of forces and phenomena, each contributing to the grand tapestry of existence in ways that we are only beginning to comprehend. As we embark on this journey of discovery, let us do so with a sense of humility and wonder, ever mindful of the profound mysteries that lie beyond our grasp and the boundless potential for new knowledge that awaits us in the vast expanse of the cosmos. In the words of the great astronomer Carl Sagan, "Somewhere, something incredible is waiting to be known." It is our shared mission to seek out that incredible something, to push the boundaries of human understanding, and to embrace the unknown with the courage and curiosity